Okay, so this is question 6 of the set you sent me. It says a bag contains 2 gold, 6 silver, and 28 black marbles. Someone offers to play this game. Randomly select 1 marble from the bag. If it is gold, you win 4. If it's silver, you win 6. And if it's black, you lose 1. What's the expected value? Every single time you have an expected value problem, I like to draw this chart. So I have 3 vertical lines. And then depending on how many outcomes I have, I'm going to have that many horizontal lines. So I'll have 3 horizontal lines here as well. So along the top, I'm going to label it like this. This is going to be outcome, payout, probability, and the last column is going to be multiply. So our outcomes here, I can get a gold marble, a silver marble, or a black marble. So what do I get if I pick a gold marble? Well, if I pick a gold marble, it says you win 4. If I pick a silver marble, you win 2. And black are going to lose 1. So that's going to be a -1. So the probability of each situation, I have 2 gold marbles out of a total of, what's that, 36. So this is going to be 2 out of 36. Probability of a silver, there are 6 silver, so that's going to be 6 out of 36. And then we have 28 black, so that's going to be 28 out of 36. And the last step is just to take these 2 columns and multiply them together. So I get 4 times 2/36 is 8/36. 2 times 6/36 is 12/36. And -1 times 28/38. I'm sorry, that should be 36. My mistake. Is going to be -28. Oops. Come on, hands. -28/36. So now I'm just going to take this last column and add up all these values right in my calculator. So I have 8 divided by 36 plus 12 divided by 36 plus -28 divided by 36. And you get -0.22. So this is going to give me an expected value of -22 cents. Okay. This next one's going to work the same exact way. So I won't even run through it because I think you can figure this out from the example video from before. It's just they give you the exact probabilities. So you'll draw your chart. You can either win $9 or you can lose $6. Disregard the 15. So your payouts are going to be +9 and -6. Okay. See if you can figure that out from the example from before. All right, question 10 says a manufacturing machine has a 6% defect rate. If 3 items are chosen at random, what's the probability that at least one will have a defect? So, probability of at least one defect. So that means there's the probability of 1 defect, 2 defects, 3 defects. Or I can just say, all right, the only other option is there's no defects. So I can find the probability of no defects. And then just subtract that from 1 because that's the only other thing that can happen. So this is a binomial. So I'm going to go to my distributions menu. I'm looking for one specific value. So that's a binomial PDF. I have 3 trials. A success of a defect is 6% or 0.06. And I'm looking for the probability of none. So X is going to be 0. So that's my answer, but I'm going to take that and subtract it from 1 because I want the complement. So my answer here is going to be 0.1694 or 16.9%. Okay, if they wanted a full percentage, I think you can just do 17%. All right, that's 10. Okay, this says a company prices its tornadoes insurance using the following assumptions. In any calendar year, there can be at most 1 tornado. In any calendar year, the probability of the tornado is 0.11. The number of tornadoes in any calendar year is independent of the number of tornadoes in any other calendar year. That's just telling you it's a binomial. It follows the binomial distribution. So using the company's assumptions, calculate the probability that there are fewer than 3 tornadoes in a 24-year period. Probability of less than 3. Okay, but our binomial in the calculator works in a way that it says that number or less. So this is the same thing as saying probability of 2 or less. And that's what we're going to go with, 2 or less. So I'm going to use my binomial CDF now. Whoops, second distributions. Binomial CDF because I'm looking for counting up to a certain number of things. Trials, I have 24 trials. Success of any individual trial is 0.11. And I want to know the probability of 2 or less. So my answer is going to be 0.499. Whoops, 0.499. Okay. Next one. A high school baseball player has a .279 batting average. In one game, he gets 8 at-bats. What is the probability that he will get at least 4 hits? So again, probability of at least 4. Of 4 or more. Well, we can't find that unless we do each individual outcome. We can say probability of 4, probability of 5, probability of 6, probability of 7, probability of 8, and add them up. Or I can say that's the same thing as saying 1 minus the probability of 3 or less. And that I can find with the binomial CDF. So I'm just going to go back in my distributions. Binomial CDF. I have 8 at-bats, success rate of 0.279. I want to know the probability of 3 or less. So there's my answer, and I'm just going to take 1 minus that guy. So I get 0.1578. I think that's it. If you have other questions, these might match up to other questions you have, but if not, you can send me those as well. I can make you a video, no problem.